Hello and welcome to another episode of the Williams Learning Lab. In this episode, we're going to discuss base units and derived units. Let's get started. Base units are units of measurement for a single basic physical quantity that is chosen as a standard and is not defined by combining other units. Here, I'm going to show you the official 7 SI units of measurement. That's the International Standards of Measurement units. So first we have length, that's the meter, and the symbol is a lowercase m. We have mass, that's the kilogram, and the symbol is lowercase kg. Now this one's a little bit different, don't let it trip you up. Most people would think it's the gram, but the people that made the decision said they wanted the kilogram to be the base unit. But the next one is time. Time is measured in seconds, and that is a lowercase s. Electric current is the ampere, sometimes called the amp, and that's a capital A. Then there's temperature, that is in Kelvin, and that is a capital K. Amount of substance, which is very important in chemistry, is the mole, and that's abbreviated MOL. And then finally, we have luminous intensity. So that's the brightness of a light. If you want to think of it that way, that's the candela, and that is lowercase c, lowercase d. Derived units are any unit you get when you combine two or more base units in a formula. So there's a mathematical operation going on in these cases. Some examples of this is area. You take the length times the width and you get a square unit. Here, it's expressed in meters squared. And the same thing for volume. You have the length times the width times the height, and you'll have a cubic unit. In this case, we have meters cubed. Then we have things such as speed. Speed here is expressed in meters per second. So the distance divided by the time it went that distance. Force, we have something called a newton. And if you're familiar with newtons, you know that's calculated by kilograms times meters per second squared. So if you just see a newton, don't automatically assume it's a base unit. For one, base units are defined as the 7 I showed you previously, but we also consider how it was mathematically calculated to understand what a force was, in this case measured in newtons. Then we have pressure as pascals. So pascals is kind of like a newton in the sense that it's something that is calculated. So it's newtons per meter squared. So for energy, this is another derived unit because it is mathematically calculated, and often it'll be a capital J, but it can be newtons times meters for that mathematical expression. Molarity, very important in chemistry, and that is moles per liter. Okay. So here, let's classify each unit as a base unit or a derived unit. So we have a column tell us what we're measuring, then we have the unit, and then we're going to determine is it a base unit or a derived unit. So we have length. Okay, that's a meter. Well, that's a base unit. That is one of our SI units of the 7 base units we talked about. Next, we have mass in kilograms. That is a base unit. Kilograms is the official base unit of the SI unit system. Then we have volume in cubic centimeters. Okay, hopefully you got that one, and that is derived because that would be a length times the width times the height. For density, we have grams per milliliter. We haven't talked about this one. Well, you have grams divided by the volume in milliliters, so that would be a mathematical operation. We have derived. Mole, that is one of our SI base units, so that is a base unit. And then we have acceleration, meters per second squared. Okay, that would involve meters divided by seconds times seconds, so that is a derived unit. Okay? Quick quiz. Watt. Is it a base unit or derived? Most people get this one wrong. Prove you know it in the comments. Thanks for watching, guys. If you found value in this content, would you please consider liking, commenting, and subscribing? And until next time, keep on learning and think while you still can.